Observe the complexity of this disorganized maze. In modern front-end development, codebases often mirror this chaos, full of endless layers of nested HTML wrappers known as div soup. This is not an aesthetic problem, it's a failure of architectural scope. Modern browsers universally support both Flexbox and Grid. This means every user interface element requires a deliberate choice between two distinct layout systems. Developers often treat these systems as rivals. When you force one tool to solve every problem, you create cluttered, deeply nested code to compensate for that tool's natural limitations. We collaborated with the architectural analysts at Royal Research to move beyond this competition. We used their data to construct a framework for choosing the correct tool based on structural requirements. Defaulting to the wrong layout tool breaks the visual design on mobile screens and leaves behind a fragile web of legacy code that slows down engineering teams for years. The mechanical difference between these two systems depends on dimensionality. You are either working with one-dimensional alignment or two-dimensional architecture. Flexbox serves as the micro-level tool. It controls elements along a single axis, either the horizontal row or the vertical column, but it never manages both simultaneously. CSS Grid is the macro-level tool. It provides a structural framework built to manage horizontal rows and vertical columns at the same time. This side-by-side comparison shows the difference: a single line distributing nodes versus an intersecting 3x3 matrix. Correctly evaluating a UI layout requires deciding if you are arranging an internal component or drawing the external canvas. Applying a one-dimensional tool to a two-dimensional layout prevents a web application from scaling predictably. The layout lacks the rigid structure necessary to support complex growth. Clean front-end architecture begins before writing CSS. It starts by identifying whether the goal is aligning internal content or defining an external canvas. Flexbox excels when the underlying content needs to dictate the physical space it occupies. In a standard navigation bar, Flexbox allows discrete blocks to slide outward, automatically distributing equal negative space between links to create a balanced look. This is the result of the Justify Content property. You can command items to group tightly in the absolute center or spread to the far edges of the horizontal axis without changing the HTML structure. By rotating the axis, Flexbox creates equal height columns. Regardless of the text volume inside, the columns align by stretching downwards to match the height of the tallest item. This flexibility requires a trade-off. The developer surrenders strict control over exact column widths to the browser, which calculates the size based on the content. This fluidity breaks down if items wrap to a second line. Without explicit width definitions, the wrapped elements resize unpredictably to fill the remaining space. Flexbox provides fluid, internal harmony within a specific component, but it lacks the rigid scaffolding required to hold a complex page together. CSS Grid excels when the parent container must strictly dictate the exact available space to the items inside it. For a multi-widget dashboard, Grid allows you to position elements precisely. It removes the need for those nested wrapper divisions that clutter the code. Defining explicit tracks creates a two-dimensional skeleton. Here, you see UI widgets of different sizes snapping cleanly into their designated zones on the canvas. Named grid areas allow elements to layer on top of one another. These widgets anchor to the same grid coordinates, maintaining their position without disrupting the surrounding layout. This method replaces the fragile technique of absolute positioning used in Flexbox, where elements often detach from the layout flow. Mastering grid syntax requires a steeper learning curve than Flexbox, as the track sizing and naming properties are more complex. However, writing complex grid CSS completely eliminates those fragile, bloated HTML structures, making the entire codebase easier to manage long-term. On smaller screens, the two models handle layout scaling differently. Flexbox utilizes native wrapping to adjust to limited horizontal space. A row of product cards can fluidly drop to the next line as the viewport shrinks, requiring no extra media queries to maintain visibility. But Flexbox wrapping fails when a design requires a complete structural overhaul. If the mobile version needs a different visual order, Flexbox cannot easily redefine the layout. Grid can redefine the entire layout template via a single media query. A media query is a CSS rule that applies styles based on device characteristics, like screen width. Watch as this three-column grid collapses and restructures into a single vertical column instantly. Using Grid's media queries for simple wrapping is inefficient. It results in bloated CSS for a task Flexbox handles naturally. Flexbox adapts by organically flowing, while Grid adapts by mutating its skeleton. The choice depends on the severity of the layout change required for mobile users. Flexbox and Grid are a symbiotic pair. They work best when used together in a single project. This schematic illustration shows the distinction between structural and interior layout. Use Grid to build the house, and Flexbox to arrange the furniture inside. Using Grid for the macro layout and Flexbox for internal components isolates layout changes. This prevents a minor button adjustment from triggering a reflow, the browser's process of recalculating element positions, that could break the entire page's structural grid. This structural rule resolves developer choice paralysis. When starting a project, you no longer have to guess which system to use for the primary container. Mastering modern CSS requires defining precise, unbreakable boundaries for where one system ends and another begins. For junior developers, stop forcing one layout model to handle every structural challenge. Follow this tactical checklist. Navigation bars use Flexbox. Product cards need Flexbox, while dashboards require Grid. For senior engineers, the data from the Royal Research Audit confirms that combining these tools reduces the overall CSS bundle size. Standardizing this macro to micro division improves codebase readability, making complex applications easier for large teams to maintain. A master developer identifies the precise architectural moment to switch tools, rather than forcing a single model to solve every problem.